In the previous video, I explained that abstract interpretation can find runtime errors by cascading range of values from the input of your program through a mathematical representation of your code. I don't know for you, but I think I need a picture. So take this picture. The blue zone is actually the combination of values that can be experienced in a program. You see, it's a fairly complex figure. The red zones are the combination of values that harbor some kind of runtime error. Say, for example, a out-of-bound array or division by zero. Now, as you can see here, there's an intercept, right? So there's an overlap. So you know that this error can exist. Now, the problem is that in real life, you don't know what this blue figure looks like. So you need to find whether it actually covers that red zone. One way of doing this is doing testing. Those are what is going on right now with these lines being drawn. The problem is that you don't know where the bugs are lying, so you need to hit the precise discrete values to trigger the error. And even then, maybe that the effect of the error is not going to be immediately apparent to you. Maybe it's just corrupting memory, and then the real consequence is going to happen far down the line in your program execution. Oh, and also, it's not exhaustive. So even if you run tests for hundreds of thousands of years, you may never find the problem. And I'm pretty sure that your software director is not going to let you do that. The alternative is to overlay a simpler figure over the actual value. So it's a strict superset of what these realistic values are going to be. This figure, you can actually compute it. So you can determine where the overlays with the zones where you could have runtime errors occur. So here it detects like, yeah, you could have a runtime error there, but also there where it cannot happen. Maybe you need to restrict the range of values that you have at the entry of your program during the modelization, so the approximation can be a little bit smaller, such as this one. If you do this, instead of using the full range of the type, you use the functional range, then you may actually find that there's no runtime error there. This is how you're getting both no false negatives and a very low percentage of false positives. If you want to know more, I encourage you to visit our YouTube channel. We have videos that are explaining you the theory and also the practical applications of the technology. So the TrustInSoft YouTube channel, or contact me. And in the future, I may actually do a few of these videos where I'm going to actually try to apply abstract interpretation to real code.